Welcome. Going to talk a little bit about platforms today. And platforms used to be the hottest buzzword before Gen AI came along, so our attention spans have become relatively short, but that doesn't mean that platforms are either not interesting or easy or trivial to do. When we as technical folks, we always think that we are sort of the masters of the game, like we control the game, we push the technology to its limits, right? That's where stuff like AI and cloud and all the other cool stuff comes from, because we push the technology forward towards its limit. But the opposite is actually also true. We can only advance technology until we hit our own limit. You know, there's a limit to how much we can understand. There's a limit to the complexity and the dynamicity of the systems that we can build. So we very much hit our own limits as well, and that defines how far we can push the technology. And in recent years, we've actually made it worse for us. And we made it worse for us in two ways. The one thing is, we had this fantastic idea that, hey, the software delivery lifecycle that has all these handovers, and if we find a problem later, we need to go back to the beginning, so we have friction. All this is, not working as great as it should. So isn't it much better if we put everything shift left, right, in one team, cross-functional, tribes, DevOps, DevSecOps, right, put this all kind of together, and then all these transitions go away. Now, of course, what we have done is, now we made the average developer not just like a coder, understanding the language, the libraries, object-oriented design, but now you also need to be a business analyst, a security specialist, a cloud specialist, an operational specialist, right? And basically the cognitive load goes through the roof. On top of this, the kind of applications that we tend to build today, right, they're asynchronous, they're distributed, they're serverless, they're event-driven, all these kind of things, give us very nice operational characteristics, but also makes this cognitive load go up. So very much we're testing our own limits. How easy is it actually to build and to manage these kind of applications? And the answer generally is, well, not as easy as we would like. We're never short of ideas and solutions. So when I talk to customers, this is usually what they come up with. Yep, we got this because we're going to build a platform, right? And the platform is going to take all this cognitive load away and make the developers productive, but at the same time, they're complying with all the regulatory constraints you have. So the platform is the new panacea du jour, right? The platform is the thing that gets us out of our misery and solves all of our problems. And while that might give us some hope, it might not actually give us a solution unless we really understand what makes platforms work and how are platforms different from any of the other common service layers. Because let's be honest, putting common things in a common layer isn't such a novel idea. We've been doing this forever, right? How to read disk segments, into a file and make directories out of this and streams. Operating systems have been doing this for decades. Most people don't have to reinvent that. And in large organizations, you have the same thing. You have common frameworks, common base platforms, common thingies that are meant to avoid duplicate work. You build the base only once, and then you have less stuff that you need to put on top. The main driver in large organizations is simple economics, right? Writing it 5 times is more expensive than writing it once. So you want to have this common layer, it reduces cost, and the more people use the common layer, the better the economics are, because if 50 people use it, right, and you wrote it once, then you saved 49 times, right? And if people need something that isn't in the layer, well, they can come talk to us and we can put it in this kind of layer, right? And this has been nothing new. We've been doing this for a long time. The key thing, though, here is this is scale economics, right? The bigger you are, the more you benefit from the reuse, because the more cost you save, right? 50 times is better than 10 times because you save more money. To understand platforms well, we need to think about the differences between economies of scale, where being big is good, and the economies of speed, where being fast is good. And again, it's about reuse, but we're after something different. We're not after a cost reduction. That might be a nice benefit, right? But we're mostly after speed. And we're happy if a lot of people use our common layer, but we're also kind of worried about, what if I need to make a change? What if my abstraction is leaky? What if my interface isn't quite the way I wanted it to be, and now I have 100 internal teams building on this, right? We start thinking a little bit differently about it, and the last one is fundamental. If somebody needs something slightly different, I don't have to build it for them. They can build it on top of the platform, because invariably what happens is the things on the left become a victim of their own success. If many people use it, many people have ideas, many people want new things, the shared team doesn't have all the capacity and becomes a bottleneck. Now, with this in mind, the way the story continues is that the old way of building common layers essentially has a pyramid model in mind. And I always joke, right? If you do things like pyramids, keep in mind people stopped building these things 5,000 years ago. Except in IT, we seem to have a very big love for pyramids. And the reason we like pyramids so much is because the tip is small. Right? It says, oh, all you need to do to make this business application in this region or for this product or for this service line, right? All you need to do is put that little tip on top. And economically, this is great because it's very cheap to put the tip on the top. Looks good on paper, and that's why we put these pyramids on our slides all the time, but it has a flaw. I would say it makes a basic assumption that is very dangerous. The assumption that is baked in here is that you anticipate everybody's needs, right? Because how can you make the tip small? You make the tip small by knowing what everybody's gonna want, so when they come and want it, you're like, look, I have exactly what you needed. You just need to set this flag or configure this little thing or write 3 lines of code, right? Perfect. This only works because I anticipated your needs. Now, anticipating people's needs is nice, but it has some limitations. The A is you need to be incredibly smart. Like, I would not admit, or I would not claim that I can anticipate everybody's needs. And more importantly, I wouldn't want to. I don't want to anticipate everybody's needs because innovation needs to happen, right? I want people to have ideas that I did not have, that I did not anticipate, right? So even if I got it all right, tomorrow they should be building things that I did not anticipate, and that is good, because that's where new ideas, that's where innovation happens, that's where good business ideas come from, that's how we make the organization successful. So even if I could, I would not want to anticipate everybody's needs. So platforms step away from this and say, there is no tip on the pyramid. There's complex stuff at the bottom. There's the cloud and servers and hardware stuff and networking, and there's a lot of things at the bottom that I think I can make simpler. Right? Because in my organization, I can make a little bit more assumptions. My developers don't use all the 200 cloud services. They use fewer. I have certain regulatory things. Maybe all the services run in my availability zone. Maybe I have certain settings, right? There's things I can do to narrow the surface. But on top of this surface, I want innovation. I don't want the tiny tip of the pyramid. I want people to do amazing things that I did not anticipate. Now, funnily, as IT people, we always believe we invented everything because new stuff comes all the time. We also just want another one of our misconceptions, right? The one thing is we always push the technology. We learned it pushes us back. But we also think, all new ideas are ours. Well, in this case, the idea of building platforms is at least half a century old, probably older even. Like in the 70s, the car manufacturers very much started to base their success on a platform model. Now, the base assumptions looked similar to the pyramid, right? The idea was, well, why make every car model completely from scratch? Isn't it cheaper if I make the engine, the transmission, the chassis, anti-lock brakes, all this kind of stuff? I make this once, and I put different cars on top. Sounds like economies of scale, right? The more I can sort of make this common, right, and I can put cars on top, it is cheaper to build a car. But something quite interesting happened here. The idea was not to make fewer car models. The idea was not to make the pyramid and have the tiny tip on top. The idea was to make more different car models. So the car manufacturers had the same idea. They wanted more diversity, more innovation. So because of the lower cost, they could have more models. So we call this the innovation through harmonization. That's the subtitle of my book. They harmonized some part, but not out of a pure cost reduction driver, but in order to get more innovation, more model diversity, right? And this started with things like the Golf and the Jetta and the Passat, right? Slightly different price points, slightly different target audience, but same platform underneath, the Audi A4. Volkswagen was a huge user of this platform principle. And we can see this easily. I always tell people when I was a kid, you know, BMW had 3 models, the 3, the 5, and the 7. I never had any of those. That is fine, but that's all you could have. Now go to the BMW dealer or the website. What do you have? A 1, 2, 3, 4, 5, 6, 7, 8. You have an X, I believe 1, 2, 3, 4, 5, 6, 7, maybe 8, I'm not sure. You have an M, 1, 2, 3, 4, 5, 6 at least, maybe 7, right? Then you have the I, 3, 4, something more, and then you have the minis and all the other stuff. So it's about like 30 or 35 models. And each model comes with different equipment, different colors, different options, sunroof, not engine size, right? Like each of them is a full car model that you can equip. That would not be possible if they didn't have a platform strategy, right? That's how they went from 3 models to like 30-some models, because they could have this model diversity. So more innovation on the top, but also more innovation at the bottom, because the bottom half now has better economies of scale. So things like anti-lock brakes, or more recently, things like sequential gearboxes, you can amortize better across different models. So you have better economics on both sides. So more innovation here, more innovation there. So it's not about, you know, I predicted everything and you just need to put the cherry on the cake. Is I drive innovation on both sides. The cloud has done exactly the same thing. The stuff we have in the cloud, like every cloud vendor having custom CPUs, whether it's Gravitons or whatever the equivalents are, TPUs, right? Tensor units, all these kind of things, Trainium, that would not be possible without the scale of the cloud. If you didn't harmonize, people wouldn't be able to make their own processors. Like, your data center is not making its own hardware because the economics just totally don't work out. But the cloud providers, the hyperscalers, can. So it drove innovation here, but look what people build on top of the cloud, right? It's highly harmonized, but people can innovate and build things on top, whichever one they wish. I used to work at AWS until very recently on the serverless teams, and if I was in a boring customer meeting, I would always tell the customers, listen, the AWS you're buying is the same one that your competitor is buying. And the customers always go, oh, right, how can this be, right? This is like, wow, you know? It's like, yeah, that's the way it is. There's only one AWS, there's only one Azure, there's only one GCP, there's only one product, right? You're getting exactly the same thing, but whatever you put on top, that's totally up to you. And that's the magic of platforms, right? That the pyramid goes out on the top, you can harmonize, you can standardize, you can reduce complexity, but on top, right, the sky is the limit. So the magic of these platforms, and the cloud is a great example. The cloud has huge scale economics. The data centers, the overseas cables, the networking, the custom hardware, the processors, right, cost an insane amount of money, right? Like every new data center costs a couple billion euros, right? Huge scale economics, but you don't see any of this. You get the server, 50 cents an hour. Like, you get speed economics. You can have the server quickly and you pay by the hour. So they make these economies of scale hidden to you so they can use it to drive innovation, and you can use the speed economics to also drive innovation. And that indeed is magical, right? That is something we didn't do before, but it also requires us to understand really the nuances of how this works. So I like binary tests, right? I always tell people, if you build an in-house platform like IDP, internal developer platform, platform engineering, right? That's what we call these kind of things. Here is a good test for you. The test is, has somebody built something on this platform that surprises you, that you did not anticipate? If the answer is no, then like, maybe you fell back into the pyramid a little bit, right? Because people should use your platform to make novel things. Now, they might surprise you in different ways. They might build really cool applications. When I worked for the Singapore government, we made a CI/CD pipeline, and then we realized we had some customers who were deploying like crazy. And we're like, oh, this must be like the most modern continuous delivery kind of folks who use our platform. In the end, it turned out they basically abused our platform as a data delivery pipeline. They used it for data distribution. I'm like, kind of clever in a way. That's not what we built it for. We were still happy. We had to tone them down a little bit because the charging model wasn't per deployment, right? So they put a lot of stress on the system, but we were still happy. It's like, hey, you did something totally different with this thing that we didn't even think of. So yes, we deserve this check mark, and you probably get a check mark for creativity, but we do need to talk a little bit about pricing. So we were very happy about this. The one thing to keep in mind, right? Remember the double pyramid, right? The platforms have diversity on top. So that means that the platform only has value by people building on top of the platform. The platform has some capabilities and does things for you, but the key purpose of the platform is not to build things for other people, but to make it easier for the other people to build things. So you're one level removed. Now, at scale, this is extremely powerful, but it also means, right, you need the other half. Like what's on top of the platform is equally important as to what's in the platform, right? People need to go build things with it. And funnily, the car manufacturers, again, proven this for us in probably around the 80s. There's a car that's not famous for anything except for the name, and that is called the Cadillac Cimarron effect. Horrible car. We only remember it for the effect. And it came out of the seemingly clever idea. So General Motors said, like, hey, this platform thing is pretty cool. So can't we improve it? We improve it by not actually making a whole new body and all the stuff on top, but we're just going to take a Chevrolet Cavalier. We put all the options in, so it gets air conditioning, power steering, power windows, nice radio. It gets all the options, and then we call it Cadillac Cimarron. Put the label on the trunk. This is now a Cadillac. Well, you can guess how well that worked in the market. Nobody wanted to buy a Chevrolet at a Cadillac price. So what had they done? They fell back into the left-hand side model. They shrunk the top of the pyramid until the double pyramid, they shrunk the top until it looked back as a tip because they felt that it had better scale economics, which in principle it would have had, but they negated this whole, I can make more models, I can innovate. Right? And this is called badge engineering in automotive terms, right? So just sticking a different label on it doesn't work. You can't take AWS and Azure and say, hey people, I just changed the color or the login screen, and this is now the My Enterprise AWS or the My Enterprise Azure. Right? That is badge engineering. It doesn't work. Right? You didn't add value, and you didn't allow people to really put new things on top. So again, the automotive industry has tested this for us and come to the conclusion that yes, what's on top of the platform is equally important to what is inside. So with that as a framing, we want to look at platforms and the magic of platforms, I call it, from a slightly different angle. What platforms can do, they can remove constraints, right? Constraints is the stuff that we live within, right? And Ken Beck this morning, if you guys could hear, he said something really funny, right? Something cool. He said, you can ignore the constraint, but the constraint won't ignore you, right? So like, we are shaped by these constraints, so removing constraints is extremely powerful. It means we can do things that we weren't able to do before, and that's what I would call progress, right? That is cool stuff. So I spent a lot of time with IT leaders, CIOs, CTOs, chief operating officers, right, VPs of infrastructure, VPs engineering, like the people kind of run the show. And they always feel that they're living in this difficult world. It's on one hand, their boss wants them to harmonize, complexity down, standardize, cost down, right? Make the IT less complex, make it more of the same, make it cheaper. But the business says, hey, we live in a competitive environment, we need speed, we need innovation, we need agility, right? And generally it's one or the other, because if I standardize, I take choices away. If I take choices away, I might stifle innovation. So there is no happy place on this spectrum. You'll always be unhappy, right? Either you're highly harmonized and you can't do anything, or you have all these great ideas and you have a giant mess, right? Like, or a little bit of both, right? Either way, you will not be happy. So one of the coolest things that I would say we have done in the software industry over the last a decade or two is actually removing some of these constraints. And the list is fairly long. This is just a simple example, right? As I just explained, platforms can standardize things, but they don't take choice away. They actually bring more innovation. BMW has made more cars because they're standardized. People have built more cool applications on the cloud because it's standardized, right? This has gone from opposites. I can have both. Quality and speed, CI/CD, automation, automated testing, the shift left, right? All that has helped us do things faster at higher quality. What did people always used to say? Oh, quick and dirty. Well, why does it have to be dirty to be quick? Because they assumed I can only have one or the other. So we've proven them wrong, and that's pretty amazing, right? This is cool stuff. Customization and cost, right? Let's say you have an e-commerce store, you have AI services. Every customer gets a tailored experience, and it costs you nothing, especially in the cloud. It costs you pennies, if that, right? Prototyping, scalability. I worked on serverless. It's easy to muck something up, but it will scale, right? You don't have to rebuild it. If you have a good idea, in the past, you used to have to build it twice. Once to validate your idea, and then once to actually get it to scale. With serverless, you don't need to do that. This constraint has gone away. And last one is fun, right? People always say, why would anybody buy anything that's out in the open? Well, look at the open source IPOs, right? The companies that have like 90% of their product is in the open, well, and they have an IPO, they generate revenue, and often they're actually profitable. So me, this is very fun, and because that's progress. We can do things where we had to pick one or the other. Now we can pick two, and that is really cool. It makes us more productive, and quite honestly also, it makes us happier. So the platforms have a special case in here. They use standards not to take choice away, but to increase innovation. So how does this work? Well, we have, again, living examples of this. Is not something we just stumbled on. This has happened in the past. And my favorite example is always like this is far back. This is 1904 in Baltimore. Big fire, city of Baltimore burned down, very horrible. So the firemen from the surrounding cities came to help. But in the end, they couldn't do much but stand around and watch the city burn down, which is kind of the worst thing a fireman can do, right? Why was that? Because their couplings would not fit on the fire hydrants in Baltimore, right? It was an unforeseen use case. They wanted to do something new. They wanted to put fire out in an adjacent city. The system wasn't designed for this. Null pointer exception, basically, right? Is like, boom, it did not fit. So since then, there is a Baltimore standard for fire hydrants in the US so that you have more flexibility so that you can do things that you couldn't do before. So the standard actually enabled you. Side note, and the US fire hydrants are an easy example because they're above ground. In Europe, they're often in the ground, is standardization doesn't mean making everything the same. It doesn't mean one thing is better than two. You need to understand how many things you need. So the US fire hydrants, you can see this in the picture, they have two different size couplings. These are smaller, these are bigger. And that's for very important reasons, because they have two distinct use cases. The smaller ones are to attach the hose and the sprayer. The bigger ones is for the pump car. It would be too big to lug around the hose. You could say, yeah, you can put adapters and whatever, right? But remember, there's a fire burning, so it's much easier to have two different kind of connectors. So understanding the use cases and the architecture is an important precondition to selecting the right standards. It's not about having one database for everything, right? Maybe you have 2 or 3 different databases because you understand the use cases. Same with the fire hydrant. Right, if you look at the International Standards Organization, ISO, one of the earliest standards that they wrote down is the metric screw. You go to a hardware shop, you buy M3, M4, M5 screws, right? They kind of look a little bit like this, and they make sure that anything connects to anything else, right? Big innovation driver. You can build stuff and screw it together, and it will always work fine. Coming back to IT, very easy to find the prototypical example. What's the standard that has driven most innovation in the last decades in IT? HTTP. Right, or TCP before it, right, all this. HTTP made sure that any browser works with any server because it's standardized in the middle, huge innovation driver. Right? In the early browser war days, there were some ideas that, hey, only certain browser things can work with certain server features and stuff. Luckily, we got rid of most of those because that would have killed all this innovation. So we have seen standards being enablers, not disablers. You can do more things because of the standard, not fewer things, right? And that's sort of where platforms get us to think differently. And then, yeah, we here in Europe, for my North American colleagues, I always have a lecture about A4 size paper, because they use like leather and legal paper and all these ridiculous sizes, right? In Europe, we use A4 paper. A4 paper is a very precise and elaborate standard. So next time you look at your paper, right, it's exactly 210 by 297 millimeters in size. And if you put 2 A4s together, you get an A3, right? You put those together, you get an A2. And you do this 2 more times, you get an A0. And how big is an A0? It's exactly 1 square meter. Now, the next time you mail a letter, every once in a while we still do this, it's become kind of rare. So if you mail a letter and you're wondering, how much does this sheet of paper actually weigh? It is very easy. If you use 80-gram paper, that is 80 grams per square meter. A4 is 1/16, 2 to the 4th, is 1/16 of a square meter. So the paper weighs exactly 5 grams. You don't even need a calculator. Thank you to the standard, right? It is a fantastic standard, but here comes the kicker. Nobody can ever come to you and say, you know what, today I cannot be creative, I cannot be innovative because your paper is only 210 millimeters instead of maybe 220, right? It's like a completely ludicrous argument, yet in the IT, we have these discussions all the time. It's like, oh, your platform is fantastic, but if it was only like 5 millimeters bigger, right, I could actually use it, but sorry, right, I can't, right? So these standards remind us how ludicrous these arguments are. Yes, you can do anything on this, even though it's completely precise, and a good in-house platform will have those characteristics. So one of the, probably the most common saying for platforms is we stand on the shoulders of giants. And apparently it wasn't even by Isaac Newton, but it was the best picture anybody would find, so he gets the credit for it. It's like you're standing on top of something. You're standing on Azures and Googles and GCPs and AWS. You don't build stuff from scratch, right? You have a higher starting point. You see further. Very, very good. Now here comes the catch. So if we stand on top of other things, we always draw a picture like this. And the idea of doing application development on top of another layer, so this time intentionally I didn't draw a pyramid, right? I drew boxes. Yeah, every architect feels very comfortable with boxes, always good, right? Development happens on infrastructure operations, right? These people give me the hardware and the resources, network connectivity, firewalls, security, right? And I deploy my application on top, right? Again, that's how we build software. Now, somebody comes along and says, oh, platforms, and the organization says, oh, great, platform. So now I have app development and I have a platform. The problem is, where is the difference, right? And it's not a trick question. There's no visible difference. So all this stuff I just talked about is like, hold on, what happened? Where did it all go? We made a mistake here. The mistake that we made is that we used a static model, right? There's no movement in this thing. It's like you have 2 boxes there, 2 boxes there. We used a static model to depict something that's related to economies of speed. Remember, the pyramid was scale, and the platform is speed. So if we talk about speed and movement and innovation and creativity and change, we can't use a static model because all this stuff isn't depicted here, right? It's nice to draw boxes, but this cannot tell the story because we're using a static model, a structural model, to explain a dynamic process. That does not work. So once you put the movement in here, and I did this in a very simple way, right? How does software delivery work? Well, we build something, then we deploy it. The technical term is we throw it over the wall, right? Somehow it lands in the blue box, right? It runs, and then we see how it runs. Technically, right? Does it perform? Uptime is good, as well as from a business value, right? Do people use it? Do people like it? Do people complete the purchase, right? Like, we get all these kind of metrics, right? And then if it doesn't, we reboot the servers, usually doesn't help, and we log a defect, right? And we throw it back. That's like the revenge. The left part is the revenge for throwing over the wall. That's how operations gets its revenge at the application teams. Okay, I rebooted 3 times, the application still doesn't run. What a piece of garbage. And then you throw something else over the wall, and you tell them, hey, it's great now, and then it all repeats. So it doesn't work very well, right? Very obvious because there's friction in the system because it goes different teams, different incentives. So the best way that I can think of to depict a platform team is the platform team is not in the cycle. The platform team makes the cycle go faster, right? If you launch a serverless instance on your favorite cloud provider, nobody does anything at this cloud provider. How could they possibly, right? I used to have the metrics, how many container starts GCP has in like 1 month or something, and I forgot how many billions it was, right? It's like nobody does anything when you interact with a platform because it would not scale. So the platform people are the bearing. They put sort of the grease on the bearing, if you wish, so that this cycle can go faster. And as soon as they're in the cycle, oh, somebody filed a ticket, they need this to get hardware, or they need something different, that is basically a red flag. We like to help them, right, of course, but every time this needs to be a red flag, because if we go back in the cycle, we fall back into the left model, and we become a bottleneck. So platform teams are not in the cycle, they make the cycle move faster. Right, in my book, I have a whole chapter, we're not going to read through all this, to really show that traditional IT services and platforms are almost the exact opposite from each other. One is sort of cost and bottom-up driven, the other one is speed and top-down driven, right? Very different animals. They just look like 2 boxes respectively, but the story is a completely different one. So anybody who embarks on building platforms, right, better not fall into this trap. This has a footnote to it. In a lot of organizations I work with, the natural team to be selected to start building a platform is the infrastructure and operations team, right? They're the people who know the cloud well, who know the service well, if you're on premises, right? They're the people who know the bottom half, the blue box, they know very well. So like, hey, they would be well equipped to build this platform. And ironically, they're both the best and the worst people to build the platform at the same time. Yes, they are the best people because they have the most knowledge of the bottom half. Like anything that sits below application, they know best, right? They know the costing models in the cloud, they know the security settings, right? They know the constraints, regulatory stuff, they know this stuff extremely well. So from that perspective, they're the best people to build a platform. But when it comes to running a platform, interacting with it, designing the interfaces, interacting with the developers, unfortunately, they're the worst people because they're going to fall into that model, and you want exactly the opposite. And that is very delicate, right? So sometimes you make platforms teams out of a mix. You bring a few people, right? As I said, they're both the best and the worst people to make a platform. If you get all new people, they don't know any of the infrastructure, right? And let's be honest, if they tick off the infrastructure people, you're not going to deploy anything ever, right? So you need to work together. So this is one of the delicate organizational maneuvers to harvest the knowledge you have in the infrastructure teams, but also get them to think completely differently on how they're going to interact with the application teams. Well, drilling down a little bit, so we have this idea of the platform, the blue boxes, the cycle, self-service, right, economies of speed, all this cool thing. Now, our platform needs to have some sort of interface, right? The developers need to interact with this, right? This could be a portal, but portals are always a little bit tricky, right? Portals are like ClickOpsy, right? We also want automation, right? We want programmability. We want APIs in the platform. We don't want tickets, right? We want self-service. So we need some abstractions. If we want to get cognitive load down, we need to abstract away some details, right? That's the lever we have to get the cognitive load down. Now, the failure mode that I see all the time is people take the cloud services and they default some settings, right? And this has been kind of, made popular through like sane defaults, right? People say, oh, my platform provides sane defaults. Sane defaults are good. They provide a convenience, right? And they avoid mistakes by having sane defaults, but they don't abstract things. They don't necessarily reduce the cognitive load. And the best analogy you have, right, if you give your kids a jigsaw puzzle of 1,000 pieces and they struggle a little bit, now taking 100 pieces away is not going to make their life easier. It's going to make their life harder. And I see this all the time. People say like, hey, DynamoDB has a little bit too many settings, so we take some of these settings away and we default them for you. The problem is if the developers don't know what defaults you have set, they're gonna run into trouble. Like, let's say you say, we are a bank or financial, so we always want replication. Now suddenly it becomes important. Do people do local reads or do people do consistent reads, right? Consistent reads are slow and expensive and local reads are not consistent, right? So you suddenly impose something on them that is super leaky, right? It's like they need to know some of these things. Like, oh, I fixed the availability zone. We only gonna run this thing out of, let's say, West Coast US. What did you do? You made a huge latency overhead for them, right? Now the way they build the applications is gonna be different. This is not abstracted away. You made it convenient, but you didn't make it go away. You did not build an abstraction. And again, I have many examples of this. Even, every once in a while, poke the box on the AWS website. I've seen a lot of these solution constructs and says, oh, these are abstractions. And then the name of the solution construct is Lambda SQS Lambda. Now, explain to your mom what Lambda SQS Lambda is, right? Unless you know what these things are, you have no way of understanding, what these things are, right? You didn't abstract. If you use the same vocabulary, by definition, you didn't abstract anything, right? This is a convenience. It cannot be an abstraction because unless you know exactly what Lambda and SQS are, this Lambda SQS Lambda thing makes absolutely no sense to you. So you didn't reduce cognitive load. You made conveniences. Yes, you can speed a little bit up, but you didn't abstract. So abstraction is hard, like many other things. And again, one more car example. I'm a bit known for car analogies. I actually just bought another car yesterday, so I'm like, it's going to be even worse today. So I always say when the engineers, if the engineers had named the car, it would be called piston, crankshaft, gear, wheel assembly, singleton, factory, something rather, right? We love naming things by the ingredients. Why? Because A, that's what we see, right? Because we made all the pistons and crankshafts, right? So we want people to, appreciate a little bit what we have built. Now, luckily, a clever person came along and called this thing an automobile, something that moves by itself. But it is very difficult if you come from the bottom to find good abstractions. And I always like to also point fingers at myself. When Bobby Wolf and I wrote enterprise integration patterns, several of the patterns originally had very technical names. Like the scatter-gather pattern was called broadcast aggregate. And it seemed very logical to us. Oh, it's a broadcast and an aggregate, so it should be called broadcast aggregate. Piston crankshaft wheel assembly. We did exactly the same thing until we realized that the purpose of this is to scatter and gather. And we renamed the pattern. So you can go on enterprise integration patterns, scatter, gather. You will see the URL name because I never changed it. The name of the page is still broadcast aggregate. So I fall into this trap just as often as anybody else. It's hard to see your own work from the outside in, but if you want to build a good platform that reduces cognitive load, if you want to find these abstractions, right, that's what you need to do. The difference can be very subtle. And yeah, we stay with cars here, right? The pedal on your right, in the US, people always call it the gas pedal, right? It makes the car go. That is a very leaky abstraction, easily tested by the fact that electric vehicles hopefully have no gas in the batteries. That would be very bad, right? So it makes totally no sense. Now, if you call this thing the accelerator, then that abstraction survives the switch from the combustion engine to the electric motor. Yes, it accelerates the car one way or the other. You can have a hamster wheel under your hood and it will still accelerate, right? Actually, kicking the pedal for the hamster may be a bad metaphor, not very happy. So let's stick with electric cars, right? We're not kicking any hamsters, but yes, the accelerator is the purpose, the gas pedal is the implementation. So it's nuances, but the nuances are very, very important, right? It's like DynamoDB with default settings is a poor abstraction. A database that contains customer data is a much better abstraction, right? Because I gave you the purpose. This is a database that is set up so that it's appropriate to store customer data in this database. And I have other databases for you, which can only be used if there's no customer data or no PII in. I've brought a piece of my domain in there. Makes a world of difference, right? The one is by the purpose, the other one is by the technology. Now you can also overdo this. Remember the pyramid and the batch engineering, right? If you make abstractions where you say, hey, I want to make this as easy as possible for the developers, right? And I make this really high-level abstraction, the danger you run into is that you actually build an illusion. And my favorite example is RPC. Now, it can be done well, and gRPC is a nice example, but fundamentally, RPC, remote procedure call, is a dangerous abstraction, right? What is it trying to tell you? RPC, as a distributed computing interaction model, is telling you that the remote procedure call is pretty much like a local call. Just call this method, the results come back, right? It's like, it is all the same, except it's totally not. It has high latency, it has partial failures, it has implementation in different languages, it has state inconsistencies, it might need retries. Local method calls have none of this. It's like it's basically a lie, right? It's like an illusion. So if you make things too simple, you end up making illusions. People make assumptions that won't hold, and they won't be happy. At AWS, we argued about this all the time because we wanted to make, I worked on event-bridge step functions, event-driven loosely coupled distributed systems. So we wanted to make it as simple as possible to the developers, but I always said, listen, things like latency, retries, out-of-order delivery, item potency, you cannot abstract away because it's the fundamentals of distributed systems. So if you pretend they don't exist, you're leading people into a trap. Right? It's good for marketing demos, but if people build anything in production and they have no idea about out-of-order delivery or retry storms or any of this, you're making it worse for them. And of course, the counter-argument was also like, oh, you're making it too complicated. So I was always in the school of expose the essential. Essential is one of those convenient words, right? But expose the essential details, but make them easy to work with. So don't hide stuff. Let it be visible, but make it easier. Type systems, programming models, automated testing, right? All these kind of things, IDE support, plugin, visualizations, right? A million things you can do to make it easier to work with instead of just pretending it doesn't actually exist. Yes, and essential is one of those words. It's like appropriate, right? Do the appropriate thing, right? Is always right. So I use this on purpose. This is very much human judgment. Right? That's you need to know based on what your use cases are, the kind of systems that you build. In some cases, out-of-order delivery might be abstracted away, and that's totally fine. In other systems, right, if transaction order and things like that matter, you cannot abstract it away. Right? This is your domain. This is like you shaping something for your business. I call this the business technical domain. It's really where your technology and your architecture meets your business domain, like a database with customer data is very much using something from your business domain because you need to understand regulatory constraints, what customer data means, is this PII, does it need to be encrypted at rest, blah, blah, blah. It's a lot of business things, But it's also a database. It's also a technical thing. So this is sort of where business and technical domain meet. And my going in position is, unless you have a really good handle of your business technical domain, unless you can put these two things together, don't try to build a platform, right? Because that's the only way you can find these good abstractions, by taking pieces from the business and mapping it to the technology and molding these two together. So you can get things like a ledger database or a database with customer data, right? These are things that use business terms like ledger and customer, but they're still databases. So the blend of those are good candidates for a good platform. And I always remind people, coming back to the DynamoDB, right? What operating systems did not do, they didn't default the drive letter for reading disk sectors one by one to 0, right? That would be convenient, because probably I want to read off physical drive 0, but I would be still reading disk sectors one by one. No, operating systems gave us a new vocabulary. We talk about directories, we talk about files, we talk about symbolic links, right? And we read from streams. Get me next character, get me next byte. There is no word of sector in here. This is not Lambda SQS, right? They use a very different language. Now, Joel Spolsky once coined the term like all abstractions, or the law of leaky abstractions, that all abstractions are leaky. Yes, that is true, but that doesn't make them less valuable. They mostly leak on physical things, I always say. And I've talked a lot about this when people say, I want to abstract away my cloud, right? I build an abstraction layer so I can be portable across clouds. And I'm like, yes, logically, you can probably ultimately get this done. But when it comes to latency, cost, capacity, service availability in different regions, you're going to be out of luck, right? You cannot abstract away the physical properties with a logical abstraction layer, right? And that's you just need to live with, right? You're making logical abstractions. So if you need a super high-performing thing, and it's very important to you how the sectors are arranged on the disk, you might still go do this. Folks do this with networks, high-frequency trading, right? They look at the size of the packets and build hardware where they can run things in the network adapter, right? They do this, but it's like 1% of the use cases. So 99% of the time, streams work well for us. So I find this to be a very, very nice abstraction. So again, a test, right, for a good platform is the platform should expose services that the cloud provider fundamentally cannot deliver. Like AWS, Azure, and GCP will never make a database that is called database with customer data. Because it's your customers, it's your country, it's your jurisdictions, it's your line of business, it's your regulator, right? The cloud provider will not make this thing. And that makes your platform very valuable. You might think like, oh, how can I build something that the hyperscalers cannot, right? They have a lot of money and a lot of people and a lot of smarts and a lot of stuff. It's like, well, they can never build this thing, right? Because every organization would have a slightly different flavor of it, so you can, but they cannot. Right, and that's good for platform teams, right? You can do something that they cannot, but it's also a good test. That's what you're aiming for. So the DynamoDB with the availability zone or replication on or encryption on, that doesn't make the mark. You need to bring something out of your business domain. You need to understand what it's used for, right? Accelerator, not gas pedal. Automobile, not piston, crankshaft, gear, wheel assembly, right? That's what makes your platform function, and that way you get abstraction because you're using a different vocabulary. Now you talk about things differently. Few more things as we're drilling down, right, and wrote a book called The Architect Elevator. So in a way, we're writing the architect elevator down, right, from understanding platforms in the big picture to standards, to abstractions and interfaces, and now like we need to design a platform. We need to build this thing, right? We're in the engine room now. So just a few metaphors. I like metaphors. What do metaphors do? Metaphors translate something from one domain into another domain, right? This is like that. And that is very powerful because this might be very technically complicated and few people understand. So if you want to talk to people outside of your domain, a metaphor translates that into another domain and people can reason about it much more easily. Very powerful tool, right? You can talk to people much more easily. You can talk to less technical people and they can still totally understand what you're after. So one metaphor I only have two in here, is one metaphor is fruit salads versus fruit baskets. What's the fundamental difference? And again, it might seem we're splicing hairs, but the hairs here are very important. A fruit basket is a collection of fruit. Yes, it's convenient. I buy the basket only once. I don't need to buy every fruit. It's maybe a little bit prettier and presentable when it comes to the basket, but at the end of the day, I just got a pile of fruit. A fruit salad is a different product. A fruit salad has things that the fruit basket cannot really do. It's easy to put watermelon into the fruit salad, right? If in the basket that's a little bit heavy, or say jackfruit, I live in Asia, right? They're like 25 kilograms, right? Not that easily done. You can have different mixes. You can eat it on the airplane because you don't need a knife, right? All these kind of things, a fruit salad is a different product. And go to the market and compare the prices of fruit and fruit salad. Well, you will find two things. Reality always kicks in, so the fruit salads are always padded with the cheapest fruits. There's usually all apples at the bottom. That happens. But nevertheless, they fetch about 2 or 3 times the price of the fruit, right? Because they are a new product, right? They cost more than the actual fruit would, right? And that's how you want to think about your platform. What is the left side? It's like, oh, my platform instantiates like Jira and Confluence and GitHub for you, or Jenkins, let's say, right? That's like here, right? Yeah, you get these 4 things. It's very convenient, right? It's kind of nice, but you pretty much made a fruit basket. Good start. But ultimately, if you can make a salad, if you can have something that is fully cohesive and say, oh, here's your event-driven serverless, baseline for your applications, and it contains many different things, different story, right? You made something much more like fruit salad. This is more cohesive, to use sort of big IT architecture words. This is more cohesive, this is more fine-grained, and it is a different product. So I have a lot of friends, right, who said, aha, the cloud providers really sell fruit baskets, and I'm, as a platform team or as a platform company, I am making the fruit salad out of the cloud's fruit basket. And that's a great way to think about platforms, right? This is a different product. So you're adding value. You can charge a premium if your platform looks like this, not like this. Second metaphor is you might have built things in the platform that over time the cloud providers also built. Happened to me, right? Like a long time ago, I built, a CI/CD kind of, and it was in fact Jenkins. It was GitHub and Jenkins, right, at the time. And part of my platform was to make it easy for people to get a Jenkins instance and get sort of basics of CI/CD, right, working. Right? At the time, this was pretty cool stuff. Then both the GitHubs and GitLabs of the world, right, they all get GitHub Actions and all the other stuff. The cloud providers in AWS land is like code commit, code build. Yeah, code commit actually just got deprecated, right? But code build, all the other things, they started building all this stuff. So now I face a decision as an architect. Do I maintain my internal platform, or do I use the base platform? Well, the economics are very much in favor of the base platform, right? They sell this 10,000 times, I sell this 50 times if I'm lucky, right? No way I can possibly compete. So what a lot of people say rationally is I should be floating. So I call this the rising ocean level. In this case, it's good, right? The cloud provider builds stuff that you have built, and your stuff is now underwater, right? And most people will say, oh, I want to float. Right, I'm going to shed the old stuff that I built because bad economics, and I'm going to build the next cool thing for mine. I'm going to make the next fruit salad, right? I'm going to make cooler stuff. Yeah, I'm going to make the customer database that the cloud provider cannot, and I float on top, right? Because nobody drowns. It's okay. It's a submarine. It's submerged. So everybody will say floating makes more sense. But when the day comes to say, oh, it's time to shut down our platform, everybody comes, oh, migration cost. All the customers are on this thing that we build. Getting them off will cost money. Oh, the money I invested, sunk cost, right? Or the money I invested in my own platform, right? I want to amortize that. People come with a reverse logic. So these metaphors help us increase our decision discipline. We say, hey, people, didn't you remember we wanted to be floating? Because everybody wants to float until they realize the cost is sunk, and then they get cold feet or wet feet, you might say, right, in this case, and they change their opinion. So these metaphors guide our design decisions. They don't tell you what to do. You can say, I'm going to submerge, right? I don't care. My platform is great. The cloud providers built the same thing. whatever, I keep going, right? I'm not telling you one is better than the other, but I'm giving you a sort of non-threatening decision models. I'm giving you vocabulary, and you can use that in your organization to go back and say, hey, people, right? Don't you remember? We wanted to be floating. Why are we suddenly all sinking, right? Really good for architecture conversations, really good for decision discipline. So I call this the mighty metaphor, right? Use these metaphors, and the book is full of this. So I owe you a couple more answers for the wrap-up. So if you wonder how this impossible thing actually worked, it's not Gen AI or Photoshopped or anything. It's just, right, if you make the clever thing, you can actually make illusions, and in this case, they're very fun. I just wanted to show you that is actually totally real. The other thing I wanted to answer, and Ken Beck made fun out of Gen AI a little bit at the end, so I also wanted to have my little snip at Gen AI, and that is, do I really need to build a platform? Isn't Gen AI going to make a great developer experience, all the code assist, all the things, right? All the crappy things in my API, all the idiosyncrasies, all the verbosity, all the inconsistencies, all this stuff that I don't like? Gen AI is going to make this all go away, isn't it? Now, funnily, Gen AI answered his own question. So this is right out of Claude, right? I just typed the question into Claude, and here's Claude's own answer. And it says, yes, Gen AI can help a lot overcome the limitations of a poor API, but it still requires human expertise. Now, you could say maybe AI is so clever that it wants us to feel good about ourselves, why it's actually taking our jobs, but more likely than not, I trust Gen AI here, right? Building platforms, making these kind of abstractions is a very human activity. There's so much judgment in here, finding better names, finding metaphors, right? That is not stuff, the LLMs can help you come up with ideas probably, right? But it's not something they will magically do for you, right? So if you have verbose or not desirable or too big APIs, putting a platform, putting an abstraction on top with human expertise is still very, very much worthwhile. Now that leaves me only with one last piece of advice, and that is a lot of internal platform teams sell the thing on the left to the developers. They say the golden path, the super highway, right? You'll be productive, you'll be going 1,000,000 miles an hour. Yeah, there's some guardrails, whatever, don't worry so much, right? It's mostly about you and your productivity. And then when the thing gets delivered, you find out that the team spent all the budget building giant guardrails, because that's how they got funding from the infrastructure team. Look, it's more secure, we have consistency, governance, and then they had no more money to put the pavement down. So, don't be this platform team, right? Don't give people the mud path with the giant rails. Make sure that you actually give people the super highway that you promised them, because that actually makes the people more productive, and this makes them feel like they're walking to the slaughterhouse or something very unhappy, right, over there. So, in summary, right, platforms are cool, right? Platforms can do things that we didn't think we could do before. They can harmonize, but they don't constrain, they innovate, they can ensure compliance without taking choices away or making too much frictions. They can do magical things, but it's not simple to do. But if you follow some of these ideas, you use some metaphors, you have a clear view of what makes platforms actually tick, then I think it's very well worth building a platform, because you can get these things that we thought of as opposites. You can have both, and that is nothing short of magical. So the hour is pretty much up, right? There's more to tell about this topic, so if you like stories about platforms and metaphors and cars and pistons and crankshafts and fruit salads and submarines, there's always more to read. You can, architectelevator.com is my website. I blog on there, excuse me, all free content, or there's a whole book about it available as ebook and as print book. With that, I would thank you for your attention.